Hello again, once more, welcome back to the cellar, welcome to Leopard Street. Today we're going to be starting a short series, they're not going to run continuously, they're just over the next few episodes. I've mentioned I've been looking at making my own function decoders, specifically so I can put lighting in coaches but do it in a cost-effective way. Well, I've got a prototype working, so what we're going to do, we're going to have a little bit of a look at that as that runs. And then we're going to go upstairs, we're going to go to the desk and we're going to build a second one and see how it all goes. So, without further ado, to the desk. Stick around. Now, this series is going to take place over a number of episodes. They're sort of going to build on each other. There will be a few branching bits, there will be some tangents, we will have a look at some accessory decoders as they could perhaps be slightly more useful for some viewers. You never know. Anyway, so coming up, what have we got? Well, in this episode we're going to be saying hello to the ATtiny85, a small microcontroller. We're going to be asking why use that and why not just use an Arduino or an ESP32 for that matter. What is an ATtiny85? How do we program it? What we're going to do is we're going to set one up and we're going to put the classic little blink sketch on it and we're going to see how that works. Following episodes we're going to be looking at how we use DCC to power things, so instead of relying on a computer in the USB port we can actually pick the power up from the track. How do we respond to DCC instructions? We're going to look at a coach lighting circuit, which is actually where this is all building up to. And then we're going to look at, well, what else can you do with this? So, let's get on with it. Let's go say hello to the ATtiny85. Okay, hello to my new little friend here, the ATtiny85. This, if I can open the packet, is a microcontroller. It's got some siblings. There's an ATtiny25 and an ATtiny45. They differ in the amount of memory they have on board, so they're slightly less capable. And to be honest, in the sort of quantities you're going to want as a hobbyist, you may as well just buy one of these. The others are slightly cheaper, but yeah, you're talking pennies. Yeah, just get these things, it's easier. So, as you can see, this is an 8-pin integrated circuit. It's the heart of why it's a pretty good integrated circuit for use, as it's significantly smaller than the Arduino Nano, as we see on this little board here. This little chip being an Atmega 328P, one of its forms. This is smaller. You can get these smaller than this as well. This is the DIP version for using on breadboard. You can get a surface mount version, which is sort of this sort of style, just a bit smaller. But as you can see, it's smaller than the board because it doesn't have any of the other bits. It's also smaller than an ESP32. Now the actual ESP32 is this bit down here. So even if you don't want the rest of the circuit board to go with it, you've still got quite a big bit. So why does that matter? Well, if I just shift these out of the way, I'll show you where it's going at some point. It's going in one of these. Now this is one of the old Hornby clerestory coaches. As you can see, that's quite small. I've not opened one of these up yet, but when I do, that'll fit in it quite nicely. Getting an ESP32 in there? Yeah, even if it fits, it's going to be pushing it a little bit. Arduino Nano? Actually, into a brake coach, it'd probably fit. The thing is, it's not just this. There's going to be more circuit boards than just this. So, yeah, size matters. Sniggering quietly there. So, compared to the others, what have we actually got? Well, the ATtiny and the Atmega. The Atmega is essentially the Arduino Nano or the Arduino Uno. So you can see we've got 8K of program RAM instead of 32K, so we can't run as bigger programs. 512 bytes instead of 2K for variables. EEPROM, which is like electronically erasable programmable read-only memory. If you think of it as like a built-in flash card, it's not strictly speaking correct, but that's the sort of thing. 512 bytes instead of 1K. ESP, interestingly, has none. It does have a way of using onboard flash memory in a slightly different way. 16 megahertz speed. It will go up to 20, but to do it at 20, you need to use an external oscillator, which we don't have space for. It's an 8-pin thing. So if we just you see, it's got 8 pins. It's got power and ground. Leaves 6 other pins. In practice, it's 5. One of the pins is a reset pin. You can use it as an input-output pin. It's a little bit awkward. Runs on 5 volts. It will run on less, but if you drop the voltage, you lose speed. So we're going to run it on 5 volts. And we've got I2C and SPI pins. The Arduino Nano, if we just jump back onto that, if I can get hold of it, also has serial port built in. Yeah, I think it's down here somewhere, TX and RX. It's got built-in hardware for handling a serial interface. This little thingy hasn't. Less of a problem. And if we just jump back onto here, as you can see, the ESP32 wipes the floor with all of them in terms of capabilities, especially if you want Bluetooth, Wi-Fi and other bits and pieces. However, as I've noted, it's quite large. So, as we can see, it's limited, but for a basic DCC function decoder, it's quite capable. So we're not going to be clamping the external crystal onto it. That uses 2 of the pins, so straight away we've lost. We're basically down to 3 usable pins. We don't want that. This one, I'd say this is better for an accessory decoder. Typically space doesn't matter because it's on the layout somewhere rather than in a vehicle. So when we look at accessory decoders, we're going to come back to that. However, notice any other differences? Thinking this sort of thing on the end here. This is literally an 8-pin integrated circuit. There's no USB socket, none of the support stuff the Arduino Nano or ESP32 boards have. However, when this is running, you don't use the USB port, unless you want obviously to talk via the serial interface. So it's just taking up space. There's other bits and pieces on the bottom of this board. Do we really need a reset button if it's going to be sitting inside a coach? Do we need a power light? Do we need lights to say when the serial port's running? Not really. So we're going to use one of these. It's small. It can be had in a smaller size, and because it's got the I2C. Remember the video I did on the PCF 8574? Yeah, you can talk to chips like that. So if you need more I/O lines, you can have them. There are some drawbacks. Obviously, this thing can't have programs anything like as large, but there we go. So, next up, how do we program these things? Okay, so given the AT85 lacks a USB connection, how do we actually program the thing? It's a little bit easier than you might think, but we'll have to go through a few steps first. So what we're going to start with is the Arduino IDE, which you should have already, and if you haven't, previous video covers that one. We need to add another board configuration. So what we're going to do is go up to here, go to Preferences, and it's this little bit down here. This gives us, I can't make that any bigger. This gives us 3 rows of information. Now the top row is for the ESP8266, which we're not using. The bottom row is for the ESP32, teeth in. And the middle row, which is this one, is for the @tiny. Now I'm going to put this link into the description of the video. Basically I'm going to add it as I've got with the existing one and show you how to have this and how to have all 3 of them. But you put that in and you OK that, and it'll go away and it'll download all the other little bits and pieces. Now this brings in several new chips you can have. You go up here into Board, go to @tiny, and you have 2 little options here. The 25, 45, 85, which is what we're using, and the 24, 44 and 84. Now this is a similar little chip. It's got 14 pins, so you've got more input-output lines. I'm not using that one because I don't need that many input-output lines for this project. but it is a slightly more capable chip. It is slightly larger. The cost difference isn't huge, so it really comes down to what you want to use it for. I haven't got any of them. I've never played with them. To be honest, until I started doing this video, I didn't realise I actually had the board definitions loaded for them. So otherwise I might have done. But this brings the chip in. And when we select one, as you can see here, I've got the ATtiny selected. You then have to come down here and you say, well, which one is it under processor? So pick the ATtiny 85. And this bit here is very important, the clock. Now for the DCC chip, we're going to need the internal 16 megahertz clock. It's not as accurate as putting a proper crystal clock on the outside of it, but for what we're doing, it doesn't matter. It's fast enough and it's good enough. If you lower the voltage, you can only use the lower speed ones. To be honest, for some functions, they're fine. And as it says, you can put external clocks on it up to 20 megahertz. What's worth noting is the little board itself, the little beastie. If I click that, I can bring it back up. It's got no idea. Let's bring this back up on here. It's got no idea what speed it needs to run at. So we've got to tell it. So what we need to do is burn the bootloader. Now, on a normal Arduino, such as the Nano up here, that sets up quite a bit of the chip, and it gives it the thing that lets it load the Arduino code. On here it doesn't, but what it does do is it tells this little beast what speed it's supposed to go at. Now, one thing that's worth noting, if by mistake you tell it to burn an external clock and you write that code to this chip, you'll think, it doesn't work anymore. It will, but you have to put the external clock on. And if you want to reprogram it to do anything else, you have to have that external clock. So, yeah, if you do that, you're going to need to get yourself a crystal and a couple of capacitors to hook up. You can then reprogram it back to the internal one again. It'll work fine. So, what we're going to do, and you can see from the code we've got in the background here, we're going to run this little blink sketch. Very, very simple. So we need to look at how to set up this board. Now I've set this little board up. If I turn it round, it'll be the right way around. So let's have a little look at the circuit, shall we? Okay, building the circuit. Now I've obviously already built this. I built it off camera. We're going to have a look at the circuit in a sec. The only addition to it is this little LED down here. This is connected via a 1K resistor between 5 volts and ground. It's a power light. That's really all that one will do. When this board has got power, that light will come on. It's not connected to the chip in any way, shape or form. So, the circuit. We start off with our little ATtiny 85. Pin 1 here is marked with a dot. On the actual chips it's marked with a little indent, but it was much clearer to show it here. What we're going to do first off is connect power and ground. So power goes to pin 8, which is the red wire, and ground goes to pin 4, which is the black wire. We're then going to add a decoupling capacitor, 100 nanofarad ceramic basically between the two power pins. You want it as close as possible to the 5 volt supply, and then it goes into the ground. It's a little power reservoir. It handles power dips, changes minor problems on the power supply. It basically makes the circuit more reliable. You don't need it, but it's better to have it. Pin 1 is the reset pin. Now this is the special one. You can use it as an I/O line. Don't. You can, but it's awkward. So what we do here is we say, I want that to be at 5 volts. I'm going to connect it via a 10K resistor, because that means we can, if we want to, pull that down to ground with a little wire, and that will reset the chip. We're not going to do that here. We've just got the 10K resistor. In a implementation like this is actually built into a coach, that would probably just be a piece of wire. Connect that permanently to power. It can't reset. You want that 10K there if you're going to try and actually program the thing in circuit. And then we're going to add our red LED, and this is going to go from pin 5, which in Arduino terms is pin 0. Along the top here we've got pins 0, 1 and 2, which are the from the right heading leftwards, and down at the bottom we've got pins 3, 4 and 5, 5 being the reset pin, which we don't want to use. But that's the circuit we've got. Now, you may have noticed there's no connection there. Well, if we just jump back to the code for a sec, we've got in here this LED built in. Now, the Arduino Nanos have got an LED on the board. I'll just come down here. This hasn't. This thing's just a chip. I mean, there's no LED on that, so that's why we've had to build this thing in here. So if we go back to the code here, what I'm going to have to do is add a line. And it's very simple. Define LED built-in 0. And that just tells this code where I've put that thing. So, right, we're all good to go. Yeah, not quite. As we said, how the hell do you plug that in? Well, those of you who've been watching may have wondered what this board here is for. Oh, I can see the reflection of my camera. This board is from a slightly different bit of Arduino code. And what you do is you go up here to Examples, Arduino ISP, and you load this. And I'm going to bring this one up here, like so. I'll resize the window so that we can see what we're doing. And this turns your Arduino into a programmer, and that's what this board here is set up to do. You don't need these LEDs and the resistors. I've got them because they're just status lights. They work. You don't need this. This is a 0 insertion force socket. What this does is you put a chip in there, you do that and it holds it, and you do that and it releases it. Makes life quite simple. That was about 80 odd pence from AliExpress, which is why I've got one. And there's various other bits of wire. Now, this here tells you what it is you're trying to do. So it's got code and it tells you how to build it. Well, if we just jump back to my little diagram here and we go to the next one, that's what we're going to do. And if we go back on to here, as you can see, it goes into this little section here, and what we've got is this wire here goes up and across to pin 10, and these orange ones go across to various data lines on here, and there's one that goes all the way around to the clock line. So if I put this in here and we switch this on, we can program it. Key note, there's a capacitor on here. This matters, but there's a bit of a gotcha. If you put that capacitor in, you can't program this. You can program through it, so you can program things over here quite easily, but you can't reprogram this board. It's a little bit of a pain, but it also stops you reprogramming this thing by mistake, which is actually quite useful. So that capacitor, that's not mentioned in the circuit, but you need that. Otherwise, when it comes to reset this little chip at the end, it resets itself and it gets confused. So what we're going to do is I'm going to take this out of here. The editor's decision is final on this. It will come out. This, incidentally, is why I'm using this 0 insertion force socket, because I can now just drop that into there, like that. Do that. We're done. Power it off when you're doing it. That's something I would suggest. It's good practice. The other thing I will note, you can feel free to imply how I know this. I'll just plug that into there. We'll plug this into the PC. Which goes into the socket over there. So that's now powered up. That goes through its little status buzz. If you plug this in backwards, as in pin 1 is over here, you plug the power in backwards to the wrong pins, this chip gets very, very hot. Now, if you're quick, you can salvage it. You ignore the speaker and the things over to the side. If you're not quick, you can't. Yeah, you'll blow it up. So what we're going to do, leave it on there like so. We're going to have a little look over here. And this is our little sketch. And what I'm going to do is I'm going to check everything's set up. So we're on COM5, burn bootloader. should run. There we are. Now what that's done, as I said, that has now told this it's going to be using a 16 megahertz internal timer. And what I can now do is come over here. Yeah, so programmer Arduino as ISP, whatever. I'm going to upload the code to it, and hopefully this is going to work. There we go. Done. So what I now do is unplug that. I'm going to plug it back in a sec. The other thing this little board here doesn't have is a power supply, which obviously, I'm going to get this thing lined up correctly. The Arduinos have got power supplies built in. We're going to look at this in a later episode. Right, that goes into there like so. So what I now need to do is power it up. Now doing that, I'm just going to have to grab a couple of pieces of wire. Piece of wire there. I'm just grabbing some other bit. I don't want to use two that are the same colour if I can avoid it. So before I power this thing back on, I'm going to say I want a ground wire. Let's bring this up here. It's going to go from there. Let's just go back full screen on this. Wrong one. Full screen like that. So I'm going to put a ground connection to there. I'm going to put a power connection. I'll do this one at the top because it's out of the way. Power connection there. I've bridged the connections over here. What I'm now going to do is plug this back in. And if everything works, this LED will power up as power and this LED will start flashing. So let me just plug this in. And there we go. Well, we now have a blinking light. The Arduino Nano is purely providing power. Yes, now anybody who's watched any of Ian's Train of Thought videos will see he's used 555 timers, which are actually this size, to make lights blink. These chips actually cost about the same as a 555 timer, if not slightly less. And if you'll notice, I don't have anything like as many components. So in theory, if you just want to use one of these things to blink a single light on and off, yeah, you can do. Yeah, anyway. So, that's the first part of this series done. So, what we've done in this one, we've laid a little bit of a foundation. We've shown how to configure the programming environment and how to load a simple program onto one of these things. We've shown what you need to wire it up. We've sort of looked briefly at why you'd use one of these things. There are other options. I'm using these because they're cheap, they're easy to program. PIC chips is the other option, but the programmers for them can get quite expensive and the software's a bit awkward. So yeah, there we go. This thing's pretty small. You could obviously use it for model railways, for a whole load of things. You just want flashing lights, do that. I say you've got 5 input-output pins. We're going to use 4 as outputs and 1 as an input eventually to control multiple different lights, as sort of we saw in the little bit of the opening montage. So, anyway, until the next time, when we're going to look at using this bit of the board over here, which I've cunningly left empty, to power this from the DCC bus power supply, and we'll see what happens. So, until the next one, thank you very much for watching. Likes, comments, etc. are more than welcome. I'll catch you in the next one. Thank you very much, and goodbye.